What if I told you that one day, a spacecraft might take us across the stars faster than the speed of light itself? Think about it for a second. The fastest thing we know in the universe is light, and even that takes over 4 years just to reach the nearest star beyond our sun. If we try to go there with today's rockets, it wouldn't take years or even centuries. It would take tens of thousands of years. To us, that feels like forever. Humanity would be stuck in one tiny corner of the galaxy. But our curiosity doesn't stop there. Since the beginning of time, humans have always dreamed of going beyond what seems possible. Once, flying through the sky was impossible. Once, landing on the moon was just a story. Yet, step by step, those dreams became real. And now we stand at another frontier, the question of faster-than-light travel. It almost sounds like magic. Imagine entering a spacecraft in the morning, pressing a button, and before the day is over, you're standing on a planet orbiting another star. Imagine reaching other galaxies the way we travel across countries today. Whole new worlds could suddenly be within our reach. It would change everything we know about exploration, about technology, and even about life itself. For centuries, this idea has lived in our imagination, fueling science fiction stories and inspiring scientists. But here's the real surprise. It's not only science fiction. Some of the smartest minds on Earth believe that the universe itself may already hold the key. The laws of physics, the ones that seem to stop us, may also hide the solution. And if that's true, then maybe one day we could build the spacecraft that travels faster than light. Before we talk about breaking the barrier of light speed, we need to understand why it is such a big problem in the first place. According to Albert Einstein's theory of relativity, the speed of light is not just fast. It is the ultimate speed limit of the universe. Nothing with mass can go faster than it. Light travels at about 300,000 kilometers every single second. To put that into perspective, light could go around the entire Earth more than 7 times in just 1 second. That is how fast it is. Yet, even at this unimaginable speed, space is so huge that traveling between stars takes years, decades, or even longer. For example, the nearest star to us, Proxima Centauri, is over 4 light-years away. That means light, moving at top speed, still takes more than 4 years to reach it. If we tried to go there with today's spacecraft, it wouldn't take years or centuries. It would take thousands of generations. Einstein also explained that as something with mass tries to move closer to the speed of light, it becomes heavier and heavier. The faster you go, the more energy you need. And as you approach the speed of light, the energy you would need becomes infinite. In simple words, no matter how powerful your engines are, if you have mass, you cannot push past that final barrier. This is why the dream of faster-than-light travel seems impossible at first. The laws of physics as we understand them today simply don't allow it. It's like trying to break through an invisible wall that always pushes back harder the closer you get. But here's where it gets interesting. Just because you can't go faster than light doesn't mean there aren't other ways to beat the distance. Some scientists believe that instead of breaking the rules, we might be able to bend them. And that idea changes everything. If nothing can move faster than light, then how could we ever hope to visit other stars? At first glance, it feels like the dream is over. But science has a way of surprising us. Sometimes, the answer isn't to break the rules, it's to find a clever way around them. Instead of trying to push a spacecraft through space at impossible speeds, what if we could make space itself do the work? Think of it like this. Imagine standing on a piece of cloth. You can't run across it faster than your legs allow. But what if the cloth itself began to move? You wouldn't be running any faster, but you would still be carried forward. This is the basic idea behind bending spacetime. Einstein's theory didn't just put a speed limit on the universe. It also showed us that space and time are flexible. They can bend, stretch, and twist depending on gravity and energy. That means, in theory, space is not a fixed stage where everything happens. It is something we might be able to shape. This is where the famous concept of the warp drive comes in, first introduced by physicist Miguel Alcubierre in the 1990s. He suggested that instead of making a ship break the speed of light, we could create a bubble of space around it. Inside the bubble, the ship wouldn't be moving at all. Instead, the space in front of it would contract, and the space behind it would expand. To an outside observer, it would look like the ship was traveling faster than light, even though it never actually broke the cosmic speed limit. It's like surfing on a wave. The surfer isn't moving across the water faster than nature allows. The wave itself is carrying them forward. A warp spacecraft, in theory, could do the same with the fabric of space-time. This idea sounds like something straight out of science fiction, but here's the fascinating part. It doesn't break the laws of physics we know. It uses them in a different way. And that tiny detail is what keeps the dream of faster-than-light travel alive. So how would a warp spacecraft actually work? At first, the idea feels impossible to picture, but let's break it down step by step. Inside the warp drive concept, the ship itself never moves faster than light. Instead, it sits safely inside a kind of bubble. Think of it as being inside a protective pocket, where time and space are normal for you and the crew. You wouldn't feel anything strange. You wouldn't even notice you were moving. But outside the bubble, something extraordinary would be happening. The space in front of the bubble would be squeezed together, while the space behind it would be stretched out. The bubble would ride this wave of space, carrying the ship forward. To an observer on the outside, it would look like the spacecraft is racing faster than light. To those inside, it would feel like floating in stillness. A simple way to imagine this is by looking at a moving walkway in an airport. If you just stand on it, you aren't walking at all, but the floor itself carries you forward. Now imagine that walkway stretching across the galaxy. The ship doesn't need to burn fuel the whole way. The fabric of space does the carrying. In theory, the spacecraft would need a special kind of engine, not one that pushes against air or fuel, but one that can manipulate space-time itself. To do this, scientists say it would require an unusual ingredient called exotic matter. This is not something we can hold in our hands, and it doesn't behave like normal matter. Exotic matter could have negative energy, something very strange but possible in theory. It's this negative energy that might allow the warp bubble to exist. Designs for such a spacecraft are still just ideas on paper, but they often show a central ship surrounded by rings or fields that generate this bubble. The ship doesn't force its way through space. It changes the very fabric of space around it. If such a machine could ever be built, it wouldn't just change how we travel. It would completely rewrite our place in the universe. The warp drive sounds like the perfect solution. A ship that never breaks the speed limit, yet still reaches distant stars in the blink of an eye. But as exciting as it is, the challenges standing in the way are enormous, so big that some scientists wonder if it will ever be possible at all. The first challenge is energy. To bend space-time on such a scale, the ship would need a mind-blowing amount of power. Early calculations suggested it might require as much energy as an entire star produces in its lifetime. Imagine needing the energy of the sun just to take a single trip. That's far beyond anything humanity can create right now. Even if we combined every power plant on Earth, it wouldn't come close. The second challenge is the need for exotic matter. This mysterious material, with its strange negative energy, has never been produced in the amounts a warp drive would require. We know tiny hints of it exist in quantum physics, but creating enough to power a spacecraft? That's something we don't yet know how to do. It would require breakthroughs in science that we haven't made. Then comes the question of safety. If a warp bubble were ever created, what happens when it stops? Some scientists warn that all the energy gathered at the edge of the bubble could release in a deadly burst when the ship slows down. That could destroy anything in its path. Imagine arriving at another star system, only to accidentally blast it with unimaginable force. Clearly, this is something we would need to understand and control before ever attempting it. There are also questions about navigation. If space itself is bending and stretching, how do you steer? How do you know where the bubble will take you? Unlike flying an airplane or even a rocket, a warp spacecraft wouldn't be able to use traditional controls. It would need a whole new kind of guidance system, something we haven't even begun to design. All of these problems show us why faster-than-light travel remains a dream. The physics might allow it in theory, but in practice, the universe is asking for technology and energy far beyond what we currently have. And yet, even with these challenges, scientists haven't given up. Because history shows that what looks impossible today may not be impossible forever. With so many obstacles, you might wonder, why do scientists even bother thinking about faster-than-light travel? If the energy is beyond our reach, if exotic matter is only an idea, and if the risks are so great, why not just give up? The answer is simple, because human curiosity never gives up. Throughout history, Every great achievement began as something impossible. Flying was once thought to be against nature. Sailing across the oceans was seen as madness. Even sending a person to the moon was considered a fantasy until it actually happened. Each time, it was curiosity, imagination, and determination that pushed us forward. The same spirit drives the dream of traveling faster than light. In fact, scientists are already exploring the idea, even if only in tiny steps. In the 1990s, Miguel Alcubierre first laid out the math for a warp drive. Years later, NASA scientist Harold White revisited the equations and suggested that the energy requirements might be far less than we originally thought. Instead of the power of a star, maybe the energy of a planet or a very advanced reactor could be enough. That's still beyond what we can do, but it's a sign that the problem may not be as impossible as it first appeared. Beyond the equations, the dream itself is powerful. It inspires students to become scientists, engineers, and explorers. It fuels new ideas in physics and technology. Even if we never build a true warp drive, the research along the way could unlock new discoveries about space, time, and the universe itself. And then there is hope. Hope that one day, far in the future, humanity will not be limited to just one solar system. Hope that our descendants could travel to new stars, explore new planets, and perhaps even meet other civilizations. The dream of faster-than-light travel isn't just about technology. It's about the future of humanity itself. That's why scientists still dream. Because even if we can't build a warp spacecraft today, the idea pushes us to imagine, to learn, and to reach higher. And maybe, just maybe, the first blueprint for a ship faster than light is already out there, waiting for someone to discover it. So, could a spacecraft really travel faster than light? Right now, the answer is no, at least not with the technology we have today. The laws of physics set limits that seem impossible to cross, and the challenges are bigger than anything humanity has ever faced. But the story doesn't end there. If history has taught us anything, it's that today's impossible can become tomorrow's reality. Once, humans believed the Earth was the center of the universe. Once, we thought no machine could ever fly. Once, the moon was an unreachable dream. And yet, we proved ourselves wrong every single time. Faster-than-light travel may seem just as far-fetched today, but who's to say what the future will bring? Even if we never build a warp drive in our lifetime, the search for answers keeps pushing science forward. Every new discovery in physics, every new experiment with energy, every new understanding of space brings us a step closer to turning fiction into fact. The idea of faster-than-light travel is more than just a scientific puzzle. It's a vision of what humanity could become, a species not limited to one planet, or even one star, but free to explore the galaxy. So the next time you look up at the night sky, remember this. Each star shining above you could one day be within reach. The spacecraft that travels faster than light may not exist yet, but the dream is alive. And dreams have a way of turning into reality, sooner or later.